Welcome to ADF Insider. My name is Nimphius and I'm from the Oracle Application Development Tools Product Management team. In this session, which is a shortened version of a presentation originally delivered by Stephen Develer, we talk about the Java Server Faces and the ADF Lifecycle, and hopefully we provide enough information to avoid lifecycle frustrations on your side during your application development projects. Before giving you some step-by-step examples and use cases, let's have a look at the Java Server controller itself and the associated lifecycle. The lifecycle, by definition, is a series of stages through which an application request passes before a result is presented to the requester. Now, in the simplest case, which is Java Server Pages, this means a request comes in, sources are compiled, and the response is delivered. As we will see with Java Server Faces, there are some additional stages that a request has to run through before the response is delivered to the client. Because Java Server Faces handles so much more than just the Java Server Pages or even the struts technology, there are dependencies that exist between various elements in the framework to the lifecycle. For example, the UI component. They may have events associated with it, like a value change listener waiting for the value change event, waiting for the notification about the change data. The renderer that determines the visual representation of a component needs to be called before the response is sent to the client. Validators and converters needs to be called after the data coming from the client is applied to the server-side component. And then there are other events and listeners that want to be invoked to a specific time within the request lifecycle to perform its job. Now, the Java Server Faces model view controller view, as we could see here on this screen, consists of a controller, view elements, and a model. The starting point of every Java Server Faces request is the Faces servlet, which performs the navigation as defined in the Faces config file, which notifies specific face listeners. So if, for instance, your application requires to monitor the different lifecycle phases, then you can have a face listener defined in the Faces config that does that for you. But even these phases needs to be initiated, and the lifecycle listener then needs to be notified. And this is what the controller is handling. And also the controller handles the components event. I mentioned the value change event, but there's also an action event on a command component. The view, well, this is where the component sits, but the component then has an association to the model, and this is through the component model. The simplest component model is a setter and getter, which you can express in a managed bean. More complex components have more complex models, like a tree or a table. Each of the components can have converters and validators applied, and they're also associated with a renderer. Every of the boxes that now is highlighted with a blue rectangle and a blue border indicates a dependency to the lifecycle, to the Java Server Faces request lifecycle, as I'm introducing it before. So this is the basic Java Server Faces architecture. Now, from here to ADF, it's just a minor change. You see, for instance, that on the controller side, we changed the Faces config file with the ADFC config file to hold the navigation of the unbounded task flows. There are also metadata files that hold navigation defined for bounded task flows. The ADF controller, however, doesn't replace the Java Server Faces controller, but it extends its behavior. So underneath, still the face events and the component events are all handled by the Java Server Faces controller. On the view side, we replace the component model with the ADF binding. That allows you to have a declarative data to UI binding. Still, it performs the same steps, so to some point in time the binding is invoked to update the underlying model. On the underlying model, as you see, we add an additional abstraction layer, which is called the data control. The data control dispatches the request to whatever business service you configured behind it. That could be ADF Business Components, a web service, a POJO, or an EGB. Similar, if we look at the components that are dependent on the lifecycle, all the blue bordered boxes represent these kind of elements. You see that the ADF binding layer is dependent on the Java Server Faces lifecycle. So you can say Java Server Faces lifecycle rules ADF, or to put it differently, ADF is well integrated and seamlessly integrated within the Java Server Faces lifecycle, which however also means that understanding the Java Server Faces lifecycle is one of the success factors in building applications with Oracle ADF. The Java Server Faces lifecycle knows about 6 stops. The first one is the restore view. In Java Server Faces, every view is represented on the server with Java objects. This Java object tree that represents the view needs to be built on the initial request, and then for every subsequent request will be used to apply change data and to notify the model about these value changes and make sure that new data that comes into the server is updated. So if the restore view exists, then the next step would be to apply request values, because this means that obviously we do have a state that is held on the server, and so-called a local value, that needs to be updated or at least first compared to submitted values. If this goes well, the next step will be the process validation phase. Now here we convert the data that comes from the client, which typically is in a string format, to the object format that is represented by the component. Once this is successful, validation is performed on the component. So that is required field validation, length validation, pattern validation, whatever validator is applied to a component. If this is successful, the next step is the update model. Now here the value that comes from the client that gets updated on the component now is updating the business model. Now this could be a managed bean that then updates an EGB reference, or this could be the ADF binding layer. If this is successful, the next step is invoke application. Now here's where all the action listener fires. This typically would be where you navigate off to a next view, or where you just invoke new queries or some actions that you define in a managed bean method or on the binding layer. The last step always is render response. As you see, there are dotted lines going from many of these phases to the render response phase. Now this indicates that the framework itself is smart enough to detect when there is an error and immediately stop the processing of phases that haven't been processed so far. Instead, it will go straight to render response to display an error message to the user. So let's have a look at a simple request example. On an initial page request, for example, to request a view as we see here on the screen, that has an input field, a date field, and a command button to process, the first phase in the lifecycle that is requested is the restore view phase. The restore view phase now will check if this view has been requested before and if there's some existing state to it. If it doesn't find an existing state on the server side for this view, it will process with the render response phase, because there's no need to update a value, as obviously this is the first time this page got requested. The render response phase will then make everything that is required happen to render the page so we can see it on the browser. In a subsequent request, so I'll provide a name, Frank, and a date, and then I press the say hello button. This subsequent request now will also start with the restore view, and on the restore view it will now find an object state on the server side, which means it's now continuing with the second step, which is apply request values. So it will take the new values, Frank and the date, and apply it to the submitted value of a component. In Java Server Faces, we know of two component states. One is the submitted value, which is the value that comes from the client, and one is the local value, which is the current data state as it's known by the model. So throughout the apply request value, now the call that is made is to the input text component, set submitted value to Frank, and to the input date component, set submitted value to the date that I've selected. In the next step, the data is now converted to its object state. So for Frank, obviously this is a string representation, but for date, whatever comes from the client is a string, is a raw format, so to say, will now be converted into a date object. After this, validation is processed on the two fields. As we see, both of the fields are required, so that means that an error will happen if one of these fields would not contain data. In addition, other validations might be processed, like length validation, pattern validation, and so on, whatever is applied to a field. If there is a change in the data, like in our case, we now have Frank and the date added into the form where previously the data had been empty. So now this would lead to a value change event to be queued so that listeners that are assigned to it can now handle this value change. Once this all is successful, the next step is to update the model. Now, when updating the model, what will happen is that the client model that the component writes the value to is updated. In our little example, as we can see from the page source, the model that the components are bound to are within the managed bean. So there's a simple request bean, and this bean has a name property and a today property where the data will be written to. If you work with ADF, then the expression language string you see for the value property will have a form of bindings dot attribute name dot input value. So here on the model now, in our case, the set name and set today will be called to update the submitted value into the model. And then the submitted value and the local component value are cleared, so that in the process of the response, the new local value will be set as read from the model, and the submitted value is empty, because that is something that we would expect the user to provide with a next request. After update model, the invoke application phase will be invoked, and this now will invoke on our action listener property a method called say hello. Now in this example, what it does is it will read the string value from the name field and the date and concatenate this information to a greeting. As we can see, the greeting in the message box, hello Frank, and then the date associated to it. If the action property was set on a command component, and if this action property was pointing to a navigation case, then navigation to a different view would happen as well in this phase. Last but not least, the render response phase will be called to make sure that the visual representation of this change is now rendered on the client. So we see that the subsequent request goes through all of the 6 steps in the Java Server Faces lifecycle. So let's dive deep into the Java Server Faces lifecycle by exploring the immediate attribute, especially the immediate attribute if set to true. So first of all, what is the immediate attribute for, and when would you use it? First of all, the immediate attribute exists on all components. That exists on input components as well as on command components. And the use case typically is if you want to have a specific component to be processed within the lifecycle before all other components, you would set its immediate property to true. If the component then is processed and handled and everything went okay with no errors, then all the other components will be processed afterwards, as if everything was set to immediate equals false. So immediate equals true doesn't mean this component only, it only means this component first. When you have immediate equals true set on a specific component, and if within this component value change listener you want to access the values that is sent for another component which does not have immediate equals true set, then the value of that component, when you call get submitted value, is not yet converted, which means you're looking at a string representation of the data. So even if the dependent component is a date component, you currently would get a string representation. unless this component also has immediate equals true set. The reason why you want to have immediate equals true set on the UI component is to just short circuit the JSF lifecycle. For example, if you have dependent fields that you want to validate, and if a specific dependent validation fails, which could be more complex and maybe handled in a value change listener in a managed bean, then you can circuit the Java Server Faces lifecycle by calling faces context get current instance render response. This is what this is good for. A special case of the immediate equals true setting is on a command component. On a command component, it's not that all of the components run through the regular Java Server Faces lifecycle once the component that has the immediate equals true setting defined. Instead, what it will do is the command component will immediately invoke its action, and then it will continue with the render response phase, which means it drops the update model and the process validation on all the other components on the page. So this is a special case, and as you could see, the special case really makes sense if, for instance, you have a cancel button, or if all that you want to do is quickly navigate to another view without updating the form that you're currently looking at. So this is what we need to keep in mind when we continue with this session, that immediate to equals true on a UI component, on a value component, has a different behavior than if applied to command component. The first use case to start with is a very common action, which is to clear an input form so that its values are reset to the current model state. You would use this, for instance, on a cancel button. If we apply a second command button to our input form and we call it reset form, and if we link this command button to an action that will clear the name field and the date field, then pressing it will produce the validation error that you see on the dialog here. So obviously the name field doesn't have the right length and the date field is provided with the wrong format. However, our requirement was to click the reset button and not to fire validation, and then to clear the name and date fields, which basically means we need a lifecycle shortcut that bypasses validation, and we have to do it with ADF Faces on the client side and on the server side, and also bypass model update so that the user provided data doesn't end up in our persistent layer. The solution, immediate equals true. Well, I said that if we put immediate equals true onto a command component, that this is a special case of the immediate property, which means that after processing of the action and the action listener properties, the next step in the lifecycle would be render response. So basically, it would bypass process validation and the model update, which is exactly what we want. So this seems to be a very good solution, and we should maybe try it. So the solution, how it would work and how we envision it right now to work, is that having immediate equals true on the reset form button, when pressed, will submit the form, but then during apply request, where the rich input text field is updated with a frank string in this case, the action listener is invoked, and the action listener actually now sets back the name property and the today property to a null value, basically clearing out any provided value and then setting the message output to null as well. And because the update model phase is skipped, the submitted value will never ever end up in our model. Sounds like the perfect solution, doesn't it? But, well, if we implement it that way, in fact it's all happening as we thought it would, but still we are staring on existing strings. So in this case, if I provided frank and the date in the wrong format and pressed reset form, then though on the server side everything is nicely cleaned up, the view still shows wrong data. So obviously there's a side effect that comes with immediate equals true, and this is that the components itself, because the lifecycle is bypassed, the components don't reevaluate their value bindings. remember that I said in the beginning that the UI components are dependent on the lifecycle. So during the lifecycle, the components get a notification to re-evaluate the value bindings. So basically rereading the values, so to always show the correct data that is currently held in the model. So the risk with immediate equal true is that we're potentially looking at stale data. So what we need to do to handle this is we have to force the component to reread its value, which means that we need to reset the component. And here we do have three options. One is the declarative option, which is the reset action listener. Then there is a utility class that we provide within the Oracle ADF View Rich Util package called reset utils with a single method called reset. And on the individual component, like on a rich input text component, we could call reset value. What it will do in all of these three options is it will clear the submitted value and it will clear the local component value, which means that after that the component is re-evaluated. The AF Reset Action Listener is the most declarative options that we provide, and you find it under the operations category in the component palette. You would use this, for instance, on any drag and drop operation from the data control palette. So if you look at the rollback command after dragging it onto a view, you will see that this Reset Action Listener basically is applied already for you on the rendered view. However, there's a disadvantage with this declarative solution, that is that it doesn't reset child regions. Now, if a form has a region on it and you want to reset the form, you may want to reset the region as well. Now, this is not what the declarative option provides, and here this silver bullet to use would be the reset util reset method. So the reset util reset method takes one parameter, which is a UI component to start with. So typically it goes to the next container, which could be the form layout or the form itself, and then traverse all the components within the tree beneath and calls reset value on each of the components. So this ensures that the whole set of components are reset, even if they are child components. So our method that is invoked by the reset form button needs to be changed so that after setting the name to null and the date to null and the message to null, that we call reset util reset, and then from the action event we can call get component, which basically means that from the command button that is resetting the form, go one level up to the next container, which is the form, and then reset all the components within the tree. The next use case is more complex than the reset form use case, and we use this to put our understanding of the Java surfaces and ADF lifecycle on a test run. The use case actually will also show us how iteratively, with a little bit of trial and error, we get to a solution that on the path to the solution will provide us a lot of insight to the Java surfaces lifecycle. Here is the form that we know from the examples before. The difference though is that we added a third field, which is the suggest greeting field. And there's a suggest greeting button that if there is a value provided for the name field, pressing this button will add a hello prefix to the name and suggest this as a greeting, so that when the user presses say hello, this will be displayed on the message box. As you could see on this screenshot, when pressing the button, the validation will kick in, which is good for the field that we are on, the name field, which is bad for the suggest field and for the date field, because this is where we don't want to have validation to be processed, because we want to make sure that we can suggest a greeting to fill the suggest greeting field and then to select the date field. So we want to work in the order of the fields. So let's see how we probably could solve that. One of the possible solutions, and that is what we learned from the reset use case, is to use immediate equals true on the submit button to suppress validation. For this, the suggest greeting button will have immediate equals true set, as you can see on the slide, and then an action listener that basically will invoke a method on a managed bean, and from the managed bean have a reference to the value of the name, which then it will concatenate with a hello. That's the idea. However, if we do this, then it doesn't work as we expected. And the reason here is that by bypassing the process validation, we get our result, which is that the validation no longer shows, but at the same side we're bypassing the update model and the invoke application, which basically means that we're not getting the result that we were expecting, and the suggest greeting field is not refreshed. So we have to look for something different, something that might work similar, but that will make sure that the data that is provided in the name field can be looked up and read. So one of the things we can look at would be a value change event. If we provide a value to the name field, and if this value is different from the previous value, then for sure the value change listener will fire, or should fire, so to say. So that means if we change the logic that we have, so that instead of having a logic applied to the suggest and greet button, we now look at the value change event for the text input field just to set the suggest greeting, then this might do the trick. Wondering if you would buy into this solution, but let's have a look what really happens here. Well, actually what happens, it doesn't solve the problem. Though we can get by the validation error, so we can press the button, and though we see the frank as highlighted, this has nothing to do with that we cannot process the request. However, the value change listener fires during the process validation, which is in phase 3. If we put the suggest button to immediate equals true, this is exactly what we bypass and that we skip. So a value change listener doesn't help at all. Another option to try may be to put immediate equals true on the name field, because if we put immediate equals true on a name field, what it means, and this is what we learned in the beginning of this recording, that this field will be processed first, which means that after apply request value, the name field value will be converted, validated, and then the model will be updated, which means that to the time when we get to the action listener of the button, we do have a value in the model that we can read and then display on the suggest field. Sounds like a fair solution. Does it work? Not really. The reason that this doesn't work now is that though our thinking is correct and the field is processed first, now validation will happen on this field as well. And even worse, because now if we press the reset form button that we created in the previous section, then validation will fail as well. So the reset form no longer works with this solution. So obviously putting an immediate equals true on the name field doesn't help us to get our use case working. So two of the things that we tried failed. Using a value change listener doesn't work because we're bypassing validation, and adding immediate equals true on the name field doesn't work either, because this will process validation on the field, which then is not really what we want. It's no longer meeting our requirements here. So what else can we do? One of the options we haven't yet talked about is the component binding. Every component in Java Server Faces has a binding property, and this binding property could be used to create a backing bean binding, the so-called component binding, which would allow us to get a handle to the component and talk directly to the component and not to the model. On the component, as we know, there are two types of values available. The submitted value, which is the value that comes from the client, and the local value, which is the value the component read when rendering, and it reads this value from the model. Before some of you shout out loud and say, oh, component bindings are not performant enough, well, there are two different ways of getting the component binding. One is, as specified here, to use the binding property, and the other one is to use a dynamic lookup. So don't get distracted by this little difference here that I use a component binding directly. What you see, however, in the screen is that we do have two types of managed beans. So there's still the managed bean that actually represents our model, which is in view scope, so that a change of the data survives the request. And then you see there's a backing bean that I'm adding to the input text field. And the reason why we do need to use two backing beans, or two beans in general here, is that the component binding has to be in a bean that is in request scope. So it could be request scope or the backing bean scope as shown here on the screen, which is an ADF controller scope. Java Surfaces components are not serializable, and this is the reason why you want to make sure that this is in request scope. Also, components typically don't maintain state because this is what the model is for. So putting the model bean in view scope and the backing bean scope to the component will nicely separate the two different concerns and make it work. However, with this approach, what we want to do is from the view scope bean, which is executing the action listener associated to the suggest greeting command button, we want to access the component, the field component, to get its changed value. For this, the method that we use in the suggest greeting action is to use an expression language lookup to the backing bean scope bean that holds the component reference. If you read the code, it's plain Java Server Faces code, so we just go from the Faces context, get an access to the expression language context, then look up the backing bean in the backing bean scope, which gives us a reference to the backing bean class. And then on this backing bean class, what we can do is we can call get value on the value expression that we create, and this then gives us the instance of the backing bean. On this backing bean, we can now call get name field binding. So when you create a component binding, then you will get a setter and a getter for the component in this managed bean. In our case, the reference is of type rich input text field, because rich input text is the object, the Java Server Faces component object that represents the field at runtime. And then what we can do is we can also access the greeting field. So we have two references here, the name field and the greeting field. And in the next step, what we do is we call set suggested greeting, put hello, and then read from the name field the get submitted value. So we cannot look at the local value because the model hasn't been updated, because we're still running under immediate equals true on the command button, but the submitted value is available. The only thing that we have to be aware of is that the submitted value to the point that we access it is in a raw format. So in a string case, like in the name field, that's all fine. If that was a date, we would have to convert the submitted value to the date object first. Anyway, last step we do is we reset the value of the greeting field, as we have learned that if we use an immediate equals true on a command button, that the field doesn't reread its value, and this is what we needed to do. Good that we have a handle to the greeting field through the backing bean component. Now we can call reset value, and then when the screen comes back, the message should be set properly to the suggested value. Well, we are getting close here. So we see the right message, but this solution has a little problem which has to do with the validation, because we put validation on the name field for a purpose. So Frank obviously doesn't meet the required validation, which is to have a length between 7 and 13 characters. So what we want to do is to implement the use case as we envisioned it, is to enforce validation to be performed only on the name field, while still keeping with the other implementation that will bring up the suggested greeting. Good news here is it's a little fix. It's not really a big matter to close that little gap of functionality. And what we learn here is that though the immediate equals true bypasses validation, for a specific field we can queue the process of validation back in. So the same code that we had on the previous slide up to the point where we have a backing bin reference is displayed here on this screen. So then starting from the backing bin reference, we get access to the name field. And then on this name field, what we want to do, first thing, we want to call process validators. Now this will only for this field process all validation that is configured on that field. And if this validation is successful, and only then, we would concatenate the field value with the suggest greeting. And why can we use the get value now? Because we processed validation, so that means that the local value now of the field is updated. So we no longer have to use a get submitted value, so we also have the benefit of having a converted value. So if that wasn't a string value field, but a date value field, that would be now a date object to deal with. And then the last line is the same, just to reset the value. And now, voila, what we see is that if the string that we provide for the name field does not meet the requirements of the validator, we see a validation error. If it does meet the validation criteria, we see the proper suggest string. The last topic to cover is where we talk about the ADF Faces optimized lifecycle. ADF Faces is based on Java Server Faces, so it's a regular Java Server Faces framework. However, there are some functionality that is available only in ADF Faces that you don't have in Java Server Faces. And the optimized lifecycle is one of these functionalities. So the optimized lifecycle in ADF Faces puts a boundary on the page that allows the JSF lifecycle to run just on components within this boundary. So we typically refer to this as partial submit and partial refresh. In addition, ADF Faces adds a client-side lifecycle, and we've seen that in that we needed to use immediate equals true to prevent client-side validation to happen. Because one thing that ADF Faces does pretty well is to prevent unnecessary network round trips to go to the server in case of validation errors. So these are all executed as JavaScript validators on the client side, and for this reason there's a client-side lifecycle as well. In ADF Faces, most of the ADF Faces components actually leverage the optimized lifecycle and work with event boundaries. Now remember, whenever you have an ADF Faces table and you scroll the table, now these are submissions to the server to fetch more data. And while you do this, you don't see any sort of validation exception and errors on other fields. And the reason is because the event boundary is just around the table as soon as you do this. Or when you reorder columns in a table, the same. Or in a tree, when you expand a node in the tree, then nothing happens on the page, even if you have unvalidated data on the field that might not meet the validation criteria. Still, you don't see any error there. And the reason is that the event boundary will not refresh anything outside of this boundary, so that even if this data in the other fields are not valid, you can continue working with a component. You can, however, extend the event boundaries, which typically you want to do if there are dependent field updates. So let's look at our example here. So in our example, we want to change the suggest field population with an auto submit that we put on the name field. The idea is that instead of you pressing the button with the suggest field update, we want that as soon as you type a name into the name field and you step out of the field, that this will trigger a value change event, and this value change event actually should update the suggest greeting. And the code for that is what you see at the bottom of this slide. So whenever the value change event fires, then we access the suggest greeting value and update this with a new value that comes from the value change event. There is no immediate equals true button involved. This means that we're not bypassing the process validation and we don't bypass the update model. However, we don't see validation errors on the suggested greeting field, and we don't see a validation error on the date field. And the reason is because we do have an optimized lifecycle that puts an event boundary just around the input text field. So all that gets refreshed in the context of the form submit is the input text field with a name in it. So here's the example. So I put in Frank123, and when I step out, there's no validation error happening as expected, but also the suggest greeting field is not updated. And the reason is because it's not part of the event boundary, which I identified with this green rectangle here. So what we could do, we could enlarge the event root or the event boundary to include the suggest greeting field. And for this, what we do is we use the partial trigger property. So on the suggest greeting field, if I add the ID of the name field, which is IT1, to the partial triggers property, then we enlarge the event root to include the suggest greeting field. So that means with an update in the input text field, the suggest greeting field itself will be refreshed. It will be triggered, it will be part of the submit, and it will be processed properly, and then that should lead to the update. Well, not really. And the reason here is that because the suggest greeting field also has validations that need to be met by the condition on the screen. So in the suggest greeting case, the suggest greeting field is a required field. If we put the event boundary around the suggest greeting field, then we submit its value and we refresh the field. And because the value is not provided, during process validation, it's recognized that there is an error, and this way the required field error is displayed. It would work just great and brilliant if the suggest greeting field had no validation applied. So if the suggest greeting field wasn't required, it all would go through and we would see the new hello message. So the lesson we learn here is that extending or expanding the event root to include fields that also have validation requirements only work if those fields' values are provided and meet the validation requirements. So the question is, now how do we get our use case working? Well, the use case, the way we get it working is that we don't expand the event root. And instead, what we want to do is we want to handle the component refresh within code. However, let's start from top to bottom. So first of all, on the suggest greeting field, we remove the reference to the name field in the partial trigger property. This means that the event root stays just on the name field, and because it's only staying on the name field, the value change listener is executed, and in the code of the value change listener, now we access the greeting field through the backing bean reference that we also used before. So still we do have a component binding on the greeting field, and we access the greeting field through this component binding. The little code that we show at the bottom in this red rectangle will programmatically trigger the refresh of the greeting field. Because we do this as part of our coding, the submit goes through the optimized lifecycle, so it's not causing any validation to happen on the greeting field and on the date field, which is exactly what we want. But then once we processed the data that is provided in the name field, once it's updating the model, we then in the deferred manner refresh the greeting field using ADF Faces context, get current instance, and then add partial target. So this will submit the value and then refresh, deferred refresh, the greeting field. So let's have a look, and here is the result. So we do have an event root which is just around the name field, because the name field has auto submit set to true, and then the suggest greeting is refreshed during the run response phase by us adding the field to the partial trigger or the partial target list. So this concludes the presentation about the lifecycle. It's definitely hard stuff to chew on, but I hope it was helpful. So what we learned is that Java Server Faces lifecycle is required for the framework to handle component events, and this includes Oracle ADF. ADF basically hooks into the Java Server Faces lifecycle, and most of the lifecycle interaction, and you see me presenting about JSF lifecycle interaction in this session, but this all applies to ADF. So Java Server Faces rules ADF, so to say. If you have a good understanding of the request lifecycle, and if you learn how to think lifecycle, then a lot of problems won't appear as a problem anymore. They will just appear as solutions, because you kind of walk in the idea of lifecycle and you pretty much understand why things happen the way they happen, and that also helps you to avoid mistakes. ADF Faces introduce component level event boundaries, which is the optimized lifecycle, so this is not available in Java Server Faces. Well, Java Server Faces, as of Java Server Faces 2, has an Ajax functionality that would allow you to have a similar optimization working, but here we do have this integrated with the ADF Faces components, which is not the case with plain Java Server Faces. The optimized lifecycle allows us to just submit the value on a specific component without impacting any validation processing on other components.